Hello everyone. I would just like to give a presentation on the use of the data that you have been hearing about to support cumulative impact assessments. And this is really a summary of the work that we've been doing with the International Seabed Authority on the development of the Regional Environmental Management Plan for the North Atlantic Ridge. So the basis for adaptive management in any sort of management regime really comes down to three key things. The first is a clear understanding of the objectives and the desired outcomes. So that's really a plan of how you're going to proceed, the things you want to achieve, and the things you want to avoid. Second component is some sort of assessment process that allows you to decide in an informed way where all the potential positive and negative effects of any sort of development or management plan are actually going to occur. And this allows you to prioritise where you're going to put your efforts into and where you're going to think about some sort of mitigation or avoidance schemes. And finally, there needs to be a monitoring program that can test this assessment and ensure that the desired outcomes that have been identified in the first step are actually being achieved. This links directly to both the assessment stage and the monitoring stage, link directly to data, and in some cases have quite significant data requirements. What you can see here is a really detailed plan to do exactly that, working through those three stages of identifying identifying the objectives. The second stage, looking at some sort of assessment of where the risks are actually going to occur. And finally, the third stage is monitoring and validation to make sure that you're actually achieving the things that you want to achieve. What I'm going to talk today primarily about is the stage that we've been working with the International Seabed Authority on, which is really the assessment stage, working out where impacts and positive benefits are going to occur and how they might change the system. And in particular, what I'm going to be talking about is the processes that support cumulative impact assessment. Cumulative impact assessment is really where the direct effects of particular activities, such as mining or any other sort of activity, will actually touch on one part of the ecosystem, but then propagate through the rest of the ecosystem so that you see some sort of ecosystem level effects occurring, and allows you to quantify the cumulative change of multiple different activities going on in the same location or at different times. Some of the work that we've done looking at the key elements of this assessment process can be basically broken down into 5 key steps. First is an understanding of the pressures that are going to occur in the system. So what are the things that are coming in that are going to cause a change in the system? The second is what are the values? What are the things that we care about, the ecosystem components? Mixing those together and looking at causal models, building up causal models, how the ecosystem responds, how this ecosystem is linked between all the different ecosystem components. The zones of influence of the pressures. So how many different parts of the ecosystem do pressures actually touch and influence directly? And then a calculation of risk and uncertainty. So trying to understand where and how different parts of the ecosystem will change under different regimes. What we've worked with the International Seabed Authority for the North Atlantic Ridge is really a type of model called a conceptual model. The conceptual models are a very quick and simple way to begin a process of risk assessment. They're basically the working hypothesis about how we think ecosystem works. They identify all the things that we've talked about. They identify the important components of the ecosystem and the processes in the system. They document the assumptions of how these assumptions and evidence of how the components and processes are linked. They identify the linkages between the processes and anthropogenic sources and they also identify the knowledge gaps. So we worked with the International Seabed Authority and a group of people who were involved in some of the earlier workshops to build qualitative models of what the potential risks of mining operations might be on the northern Mid-Atlantic Ridge. We gathered information through working with the experts on the values, the ecosystem components, the pressures that are acting on those systems, where the potential mining activities and outfall pressures would actually occur, the zones of influence, the points where the pressures were actually touching the ecosystem components, and developed up the causal models. And we developed these for the vent systems in the northern Mid-Atlantic Ridge. And this is the model that was developed for the northern Mid-Atlantic Ridge for the vent communities. And what you can see here is that this model basically identifies where all of the different parts of the vent system are actually occurring, and how it's actually touching on how different components are linked to each other. What's not shown on this diagram, though, is where all the locations where we actually see some sort of direct impact coming into the system. And then on the left, you can see the detailed evidence and data that was used to actually identify every one of the arrows and every one of the components in this system. What's really clear here is that there is a very, very strong evidence base for each of the different linkages between each of the ecosystem components and the identity of each of those ecosystem components. It's really important to note that there is actually a lot of data sitting behind this, and what this process has done is has taken in an enormous amount of data from a wide variety of different sources and synthesized it to come up with this simplified model of the ecosystem and how the ecosystem is operating. From that system, what we can do is we can put in a number of different pressures coming into the system that identify where and how the system will change. And we can do this in looking at single pressures, so a single thing happening. So for example, the effect of habitat removal, the effect of changing hydrothermal flow, the effect of sediment clogging, or the effect of plume toxicity, and how it actually influences any one part of the ecosystem. And then we can look at how those effects propagate through the rest of the system. And you can see on the right quite clear differences between the different sorts of pressures and which parts of the ecosystem are being affected. Some of the pressures, the changes that are occurring in the system, will affect some parts of the system strongly, but other ones actually affect almost all of the system in an extremely strong way. And that would be the case in the case of the hydrothermal flow reducing the subsurface connectivity within the vent field has a very big effect on the entire system. We can also look at combinations of pressures and scenarios where multiple pressures are acting at the same time. And in those situations, it's a truly cumulative sort of analysis where we have multiple pressures acting on the system in the same way in different places at the same time and causing large changes to the system, the ecosystem as we know it. This allows us to really understand what the cumulative impacts of any sort of mining activity and any sort of pressure and coming out of any of those mining activities. It's important because it identifies the places where we're most likely to see change and allows for mitigation and avoidance options that might not have been identified before. It also allows us to identify the parts of the ecosystem that are most likely to be the best indicators for detecting those changes so that we can actually detect them and avoid them where they might occur. The key next steps out of this process. So we've worked through that process of doing an assessment and identifying where the cumulative impacts are going to be and where potentially we might want to be monitoring. The next steps, should they be taken, would be to start to identify the monitoring questions. What will be impacted by what pressures and over what timescales? What the indicators will be, what the best indicators for our species groups for this impact might be, and standard operating procedures for monitoring. We want to ensure that any measurements that are taken are repeatable and comparable. The data and ecosystem understanding support every step in this process. So all of the components around data management, around access to data, around being able to use data in a variety of different scenarios are incredibly important to actually support this development of cumulative impacts and the understanding of how systems will change with different sorts of activities. Thank you very much, and have a good day.